Okay, a third problem is asking us what are the basic trigonometric identities. So our third problem here asks us about basic trig identities. Now this is actually quite a broad answer, because if they're just asking us what are the trig identities, it would be easier, because although there's like a lot of trig identities, but basic trig identities is kind of an odd question, because we can have a lot of trig identities, and which ones of them are basic, I guess that kind of depends on your school level, whether you're like in high school or middle school, and that kind of like determines which trigonometric identities are basic for you, and also like your schooling system for which province you're in, or which state you're in, or even which country you're in. So yeah, it's actually a quite broad question, but I think the most basic trig identities are I think the most basic ones I guess we can start with the tan identities. So we know the tan of theta, or tan of x, is equals to the opposite, or I guess is equals to sine of theta over cos of theta, and the cotangent of x is equals to cos of x over sine of x, which is also equals to 1 over tan of x. So this is kind of the most basic trig identities. There are also other trig identities. For example, we have the trig identity of cosecant of x and secant of x. So cosecant of x is equals to 1 over sine of x, and the secant of x is equals to 1 over the cosine of x. These are another kind of trig identities that are quite common. And some other trig identities include the double angle formulae. Let's write another box over here. The double angle formulae. And there are three main ones. The first is the sine of 2x is equals to 2 sine of x, cosine of x. And there's also the cosine of 2x. So that basically helps you to solve, to use like sine of x and cos of x to find the sine of 2x. So like when the size of your angle is doubled, how do you like find that those kind of values using like existing using existing angles? Okay, so the cosine of x equals to cos squared x minus sine squared x, and it also equals to 2 sine squared x minus 1, or sorry, it's equals to 2 cos squared x minus 1, 2 cos squared x minus 1, and also equals to 1 minus 2 sine squared, 1 minus 2 sine squared x. Okay, it's really easy to mix the order of these two formula up, so you got to be really careful of that. But these three are kind of the most common formula of cos 2x. There's also an extra one that I probably should cover. Here, let's erase the box. We have another one that's about tan x. So tan of 2x is equals to 2 tan of x over y minus tan squared x. These are kind of all the double angle formulae, or I guess double angle identities, because they're both referring to the same thing, that some people call them formulae and some people call them identities. So yeah, these are kind of the most common ones. There's also other ones about the sum and difference of the angle, sum and difference identities, and it basically helps you to solve the angle, two angles, the sine of two angles added together, and the cosine of two angles added together or subtracted together, and the tangent of two angles of different sizes added or subtracted together. These are called the sum and difference identities. I'm not going to write them out, but they're also really common angle identities. I think these are kind of the 4 categories that are kind of the most common, or I guess there's another category that are pretty common, and they're called the Pythagorean. I think Pythai is like A. Pythagoras. Pythagorean identities. I think there are 2 main ones, or there are 3 main ones actually. One's about cosine squared x plus sine squared x equals to 1. They're the most common one that you'll probably see. And they're called Pythagorean identities because you know the Pythagoras theorem is a squared plus b squared equals c squared. And the Pythagorean identities are derived using the Pythagoras, or they can be derived using the Pythagoras theorem, and they also have the squares in them. So it's kind of like suitable to name them Pythagorean identities. And the other 2 Pythagorean identities for trigonometry we have is 1 plus tan squared x equals secant squared x, and cosecant squared x. The third one this one you're probably not going to see as often, but the first 2 ones are kind of what you'll see more often. So these 2 are probably what you'll see more often. These are very useful, but I'm not sure you're going to see them until, I'm not sure if you're going to see them until like you're in later grade, like probably grade 11 or 12 in a Canadian school system. And these 2 are also kind of like more common. You're probably going to see them grade 10 or 11. Oopsie, the stars are not going with me. Alright, but basically I was referring to sine 2x and cos 2x of double angle identities. But these ones, the tangent, you're going to see them everywhere. It's one of the most common ones that you're going to see. Cotangent, you're probably going to see it too, so it's cosecant and secant. They're all quite common. Okay, but the third one, right, let me just write it down as well. So it's about cosecant squared x. Cosecant squared x equals to, it's really weird. Whoopsie. Let me try to erase it. I'm just going to write it in another way so that it's, let's just write it in the way of 1 plus cotangent of x equals to cosecant of x squared. Whoopsie. So 1 plus cotangent of x squared equals to cosecant of x squared. That's kind of our third one of our Pythagorean identities. But again, it's not as common as the other ones. So yes, this is a common one, this is a common one, this is common, and this is probably the most common one you'll see, which is the tangent of x. Cool. So these are kind of like the more common identities, in my opinion. But again, there's like a lot of trigonometric identities. So depends on your schooling system, which of them are basic. It kind of depends on your school system and which kind of area of mathematics that you're going to cover. Now let's look at the sample solution over here. They separated them into the 4 categories. They have the cosine. Yes, I think we covered those as well. Did we? No, we actually, yes, we did. Kind of. I always wrote about secant and, or actually no, I wrote about all of them. I put the cotangent one here, and I wrote about secant and cosecant over here. Yes, the reciprocal identities. They basically wrote it in like the other way. So basically, we know that, for example, the cosine of x is equal to 1 over secant of x. And so the secant of x, if you multiply secant of x on both sides and divide cos of x on both sides, we would get to this formula written down over here. But then essentially, this formula is the same as the one that we're given. We also have the ratio identities, again, which we had over here. And they had the Pythagorean identities. Yep, they're the common one. I had it here as our last one. They also have the even and odd identities, or like the negative identities. They're actually you don't really need to memorize those. You might need to like memorize the other one, but this you don't need to memorize because you can just derive them or see them really quickly using the unit circle. So these are kind of like, or not using the unit circle. I guess you can also do it using the unit circle, but they're like, they can be, you can just like see them using the unit circle or like using the graphs of cosine, sine, and tangent. So you don't need to memorize those over here. Okay, let's just see something like, good job, the solution is correct, the solution is correct. Cool, let's move on to our next problem. They didn't mention double angle identities or sum and difference identities. I presume they just don't think these are as basic as the other ones, but I think they appear quite often. But again, it depends on which schooling system you're in. Alright, that sounds our third problem about basic trigonometric identities. Let's check what other questions